welcome to Linux channel. So it's been a while ever since I shot any video episode. So part of the reason is I was busy with some stuff. Other than that, meanwhile, my mom got sick in the month of December 2023, and then she got admitted. She got a stroke actually, and it was a bit severe. She was paralyzed and things like that. And then she was like bedridden, fed through the tube and things like that. And then she expired in the month of December itself. So it was a little bit a time which I was busy with all these things, and also I was being myself in spiritual stuff. As most of you are aware, I was mostly contemplating the purpose of life, and so I was going through so much of stuff. And then I thought, let me take a break. And every day after that, I was thinking I should do something, resume these videos, but I was not able to do because I was again getting distracted with all these thoughts. It keep popping up. You just keep remembering that presence of a person and things like that. So absence of a person, and that too it happened quite fast. I mean, it's just a duration of around 15 days. She got sick for the first time, and then she passed away. So it is quite fast, and it's not like she was bedridden and been at home for many months and things like that. So I thought, let's just restore this video episode. So one humble request for viewers is, since I'm kind of distracted, I thought let me take a video episode on a topic which I feel somewhat quickly comfortable to handle, and maybe it is also helpful to most viewers who are into the journey of Linux kernel network development. So in case if you are looking for any specific topics, and in case if I have a good foothold or prior experience or knowledge, I can cover those topics. So feel free to let know in the comments or mail, whatever you prefer. You can let know the topics which you are looking for, and in case if I'm good at, I'm going to cover in upcoming video episodes. So that should help me to overcome this this situation, because I feel that shooting videos like this is also a way to overcome the thing which I am going through as of now. So anyway, we start this episode. So one of the things I was doing is going through this TUN source code of the kernel source. I thought since it is also one of the drivers, and as I say in many videos, the thing which fascinates me is all this type of virtual drivers, the TUN, with loopback and things like that, rather than the real physical network drivers. The reason is these virtual drivers will have its own significance, and you can do fantastic things out of them. I have even covered various topics about the same, including as interesting interface type called dummy interface. So as a part of that, you can see even I have covered various episodes on TUN interface. By the way, I have transitioning my old Linux channel website to a newer website. So sometimes at times you may get some topics in the old websites, and sometimes if you open a old website, it will redirect to the new website. So not to panic, the new one is a dedicated Linux channel website. The old one I started earlier as Toffee project, and Linux channel got added in the later stages as a subdomain. Okay, so hence the domain name itself is linuxchannel.thetoffeeproject.org. So versus now you can see here it is thelinuxchannel.org. it's a dedicated Linux channel website. I'm in the process of migrating some of the topics and pages from there to here. So hence some you may find there, some you can find here. One advantage with the new website is all these topics I have put it in the nice order. So you can do either a search and go and get an article. You can also do is go to this videos tab. You can see here, you can go to this videos tab, and you will find all this topics, and you can click any topic. Say for instance, I can refer the raw socket examples which I covered long ago, and then we can relate with this TUN tab source code. So hence you go here and you can search for raw socket. You can see here Linux user space raw socket programming, because raw socket you are actually leveraging the user space to send receive packets from user space to the kernel directly and pass on to the kernel network drivers. So that's what it is. So hence you can see it's a part of user space systems architecture and networking. This is the main topic. Under that there is a subtopic Linux user space socket programming, raw socket programming, and then you can see various other topics. So you can directly go here, no need to search and then go to that relevant article. Of course you can do that, even you can do a Google search and land on that article, but you can also do this way as well. So you can see here in this section there are various topics, articles or video articles covered, and you can browse through these video articles. So as a part of this episode, so we take any of this raw socket code. Let's take example this OSPF packets and HTTP packets. See, one thing you can find in the source code quite commonly is see, if you go through the source code, you get this ioctl API. See, in this case it is system ioctl get interface index. So we are getting that net device index of the kernel data structure, which is a linked list, and it will have an interface index. So we get that index to do further operations. So in this case we are doing this further operation to do this bind call. We are getting this interface index, and so we are using this ioctl call. And as I said in the previous or many episodes in the past, whenever you do ifconfig command, if you do any IP command in user space, these commands eventually translate to these type of system APIs, which will propagate your configuration what you provide in the user space to the kernel space. It doesn't matter which Linux distribution you use and things like that. So you use Ubuntu, you use Fedora, or you use something like a router operating system like OpenWRT. No matter which operating system you use, eventually this is what it propagates. So in the case of operating system, you may have some type of user land network configuration management thing. In the case of Ubuntu, the regular Ubuntu, there is something called network manager. The desktop Ubuntu's like this. Mine is a Ubuntu. So it is XFCE based Ubuntu, and in case if you use the stock Ubuntu, they may use network manager. So usually UI based distributions will use network manager, and if you use Ubuntu server, you may have something called netplan. It is quite common. Some distributions uses netplan. So netplan is quite versatile for distributions without any UI interface. It will have some type of YAML representation of the network configuration, etc network configuration of this network ports. But eventually again it will translate them into these type of system calls, and it will propagate to the kernel driver settings or port settings. So that's what happens. Hence you have this ioctl APIs which can be called from user space, pass on a command like this. In this case you are telling a get command. You can also do a set command in case if you are doing any interface MTU and things like that. And again you can find them over here. If you come back here, I have covered long ago an episode on this net tools or stuff like that, where I have discussed an implementation of ifconfig command. You can see here. So these things are covered long ago. Of course, since I ported from that website to this website, it shows as some October 2023, but it is a very old article, very old video episode. And in this I have done source code and also provided a GitHub link of that netlink nettools this thing project source code. So if you go through, you can find such APIs. Let's just go here, nettools. Yeah, you can see nettools GitHub source code. You will find in the source code various instances they use this ioctl APIs. Okay, So that's what it is. I have since I have covered in dedicated article, I mean dedicated videos, I'm not sure how far is it necessary for this episode. So let's do a very quick search ioctl and search for various instances. See, in this case he is doing this system ioctl interface flags, he is doing a get operation, he is doing a set operation, and let's just search for other instances. See, if you see here interface net mask, and this is what is passing or getting this network mask. For setting a network mask, is doing this set network interface mask. Okay, so things like that. So this is what happens in the user space. Yeah, here you can see is doing a set interface MTU. So if you do if config is0 MTU and then you provide any value, it essentially translates to this. Hence you can write your own C code, and you can also set via that. It's not just you use user space commands like this. So you can do if config, you can do if config, provide any interface name. I don't want to provide this. Let's imagine eth0 MTU. I can provide something like this. So that will be sent to the kernel using this thing. Since there is no interface, it is throwing this error. So let's imagine there is a real interface exists. So this is how you can do. And we can also do a Google search if config set MTU, and you can see the command is the same. Yeah. If config grep MTU, it is there over here. Anyway, it shows the MTU value, and you can also set it by this way actually. So you can do this port name and then MTU, and then you can provide the MTU value. Okay, so this is how you can set. The thing is, whether you use this if config command or you use IP command, whichever way it is, it will be using in the backend like you saw in the source code ioctl APIs. So these ioctl APIs, the whole context of this video is this: as you provide in the user space gets translated in the kernel space, it will get handled in the kernel space, and then it will set it internally. So that we can see a simple sample code walk of this TUN tap interface. In the case of TUN tap interface, let's assume you do any of this operation, how it handles how it is being implemented in the kernel space. So hence, if you go here, the TUN tap source code, yeah, over here this is drivers net tun.c. So hence we go to this TUN tap source code. I will also open this tap interface tab.c. So we have in one tab this browser tab tap interface. Yeah, we have in another tab this TUN interface. So if you see the source code, you have this API they implemented TUN chr ioctl. So this is the API which is having all these routines, and you can see it is handling this ioctl settings actually. You can see there. So whereas in the case of tab driver, we can see ioctl. So ioctl stands for IO control. So you can see there again there is a tap IO control, and you can see there they have that implementation. So whenever we provide in the user space, that eventually comes here in the kernel side. The driver handles these things or these requests, and it will either send back or it will get and set internally. So if you use any set operations, it has to set in the kernel space. Whenever you do get operation, kernel sends back, which it will be received in the user space. Hence you can see the relevant code over here. Okay, so in this case you can see SIOC get interface hardware address, which means we are getting its hardware address. If it is Ethernet interface, it is MAC address. Okay, so you can see that in this case it is a get operation, this is a set operation, and you can see how they are handling in the other side of the kernel, because that's where actually it is done. Okay, so same thing you can see in the TUN interface as well. The hardware address, let's search for this, get interface hardware address. Yeah, you can see their interface hardware address, and they are using an API. Through that it is received, and then it is sent back to copy to user. They are populating in this data structure obviously. So if you go to this socket code, my raw socket code, yeah, the raw socket code. So what we do is, effectively we will populate a data structure and send it to the kernel. Yeah, you can see there, before this ioctl API, we get this data structure, we populate this data structure, and we send it to the kernel. Kernel populates the values in that data structure member variables, and then we will receive it back. So in this case, you can see we are sending this IFR, we are telling the interface name, and then we are doing this operation, and it is sending back us the interface index into this member variable of this IFR data structure. So you can see the interface index is populated over here, that we can read it. So that's what it is. So you are giving a container saying this is the where I need the value, and it is kernel is populating in that container and giving back to the user space. So this is what happens. So hence you can see the implementation is doing this copy to user, and before that is populating this data structure and is giving back. So this is what is the implementation. Let's see if there is an implementation for this set and get interface index as well. Okay, so it is not there. Again, I am not sure what extent it is, things are to be done here, what extent it is handled as it is as a part of general driver and things like that. Again, I'm not an entire expert on this. I was just doing a code walk. I thought, let me shoot a video episode, so that I do get lot of queries from especially beginner, where to start and things like that. So when you do that, especially when you just enter into kernel space development, you have to go through various aspects like that to get an overall idea that these are various parts which I need to cover eventually, so that it gives me an understanding that when things are done in the user space, how things are handled in the kernel space actually. So you can see there. So in the case of MTU, let's see if there is any implementation of that. MTU, max MTU. We can go to this section. Interface MTU. We see if this is implemented over here. It's not there. Once again, I am not sure, because some extent it may be done as a part of basic driver support, and some which are done inside here explicitly. So there can be a split, but obviously when the TUN type interface comes up, you can do all these things. Okay, which means there is somewhere kernel is anyway doing it. There is another way to find out is, anyway you can open this source code. What you do is, you can anyway search that label, and you can see that where it is handled. You can see here device ioctl, so which means this is a primary device IO control, which is maybe common for all drivers. So you don't need to explicitly populate these things. Hence, if you see here, we open this device ioctl, and you can see here is the implementation of this, and here you can see here it is all implemented over here, ioctl, and here is the MTU as well. Okay, and here is the device interface hardware address. But one thing I need to understand is why there is this over here, why there is something implemented. But again, I need to see. So let's say we check this and search if that is here. So we can see here it is there, as well as here it is there, but again I'm not sure. But one thing is, you can see here, this is where it is implemented. So as I always say, one thing when you have such questions or confusion in mind is, you can do simple print messages and see whenever you do this ioctl operation in the user space, confirm where it is triggering in the kernel space source code. Of course, even that I can do if I need for sure where this is happening. So if I have to doubly sure that where this is happening, one thing I can do is just put a print messages here, compile the kernel, and then see that do that operation, interface MTU or something, or this thing, get hardware address. So see that whenever you do that operation, which part of the code it is getting triggered. Is it the part of this TUN tap handled ioctl section, or the other primary device ioctl.c? Okay, so things like that. Okay, hope you got an idea. The kernel code is ever evolving. There's nothing that we can take as a basis. This is very much needed if you are a beginner. This is not like you just take some textbook definition and then you start teaching that this is how kernel works and then go about it. It's absolutely wrong. The kernel is always evolving, it always changes. Hence, you have to check what is relevant in this current version of the kernel to confirm that is the thing. Hence, I'm always keeping that uncertainty. It's not that I obviously accept and allow myself that I'm not an expert in everything when it comes to Linux kernel space, but again we need to keep this open-mindedness, because kernel is ever evolving. It always changes. Today it may be this, tomorrow it may be something else. This they may actually remove, and then they may try to generalize and things like that. Hence, never come with a concrete mindset that this is how it works. Just keep that uncertainty in mind. If you find some anomaly, just confirm it, do a simple print and then compile the code and then check, verify how it works. And things may be different in this driver versus things may be different in some other driver. Hence, you can do that and then you can get an opinion. And then that opinion, now you know conclusively that this is how it happens. But time to time, have that flexibility in mind that these things may change as the kernel code always evolves actually. So hence I'm saying go with that note and do your own investigation. And in case if you have any queries, you can ask me. In case if I have some concrete investigation done, I can quickly share my results. Actually, it's as simple as that. Or if I have vague idea, then I can give you some pointers. You can perhaps look over here and look over here and see how it happens. So this way I can guide you as a mentor, whether you come as a paid mentorship program as a student, or you are a casual viewer of mine and you are in your journey of understanding and getting into Linux kernel network software development. Hope you enjoyed this episode. Be in touch via mail or post your queries in YouTube comments. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.